Hello guys, welcome back to another video. Today I'll be participating in Biweekly contest 110. It's finally a commentary video after a very long time. I'll try to explain the thought process and at the same time I'll try to solve problems as fast as I can. Hope I perform well today. Count the balance after round purchase. Initially I have a bank account balance of $100 and teacher purchase amount representing the amount you will spend on a purchase in dollars. At the store, you will make the purchase amount is around the nearest multiple of 100. You put a non-negative amount, a rounded amount, is that is a multiple of 10 is minimized. Okay, if there are more than one nearest multiple of 10, the largest multiple is chosen. Return an integer denoting our current account balance after making a purchase worth purchase amount dollars from the source store. Okay, initially I have this much amount and I have to make this payment. Okay, so the purchase amount is rounded to the nearest multiple of 10. So 9 is very close to 10. Okay, I get it. Let's call it x. Initially we have 100. We'll try to make it x equal to if to one of the nearest integer. So we can either have mhm, is 0 also multiple of 10. Let's assume for now no. Okay, so what we can do is you have the first digit and I can either have and let's say second number is first plus 1. So it's either first into 10 or second into 10. Absolute of into 10 minus x is less than absolute of first second into 10 minus x. Will return 100 minus first into 10. Else if it's equal or if that one is greater, we'll simply return second into 10. I think this will work. Um, okay. Okay, we'll have to handle that separately. If x is less than 10, we'll simply do 90. What in case of, okay, 0 is also considered to be a multiple of 10. If x is less than 5, we'll return 100, else we'll return, yeah, right. Even if it's equal to 5, we'll return 10 in that case. Okay, let's do it. Interesting. So since x is already greater than 10, we can have it equal to, so it will be 10 in case if x is equal to 100. Second will be x approach plus 1. If this is a smaller, we'll purchase that then, right? There's more than one near multiple of 10, then the largest multiple is chosen. That's why we're making sure that this one is lower, so it has to be lesser for sure than this one. Even if it's equal, we'll return this. Let's say for 95, 85, 100. What do we get? Why is it taking so long? Okay, they took 20 off, or they took 90 off, right? They took 100 off. What could be wrong then? We're not using have anywhere. This looks correct, but this is not. Where could it go wrong? For like 10, 190. What am I doing wrong? What? What did I change? Oh, there was a loop, but I don't think it was causing that much issue. Insert greatest common divisor, a linked list given the head of numbers in which each node contains an integer value between every pair of which is a node. Insert a new node with a value equal to the greatest common GCD of them. Okay, so GCD of this is okay, cool. Um, 4, 6, and 10 it was 2, 4, 10, and 3 it was 1. Isn't always even. No, okay. We have GCD of and has next value. We can also have temp, which is pointing to our head, and we can have a new variable, new new node with element as le. Now we'll store the next of head in temp, and next of head will become node. Nodes next will become temp. Now head will directly go to the nodes next. Yeah, that is correct. So we have two temp now. Let's call it dummy. Eight in 6, 6, 2, 10, 1, 3, 7. I hope this is correct. Let's make sure for once again. We found the GCD, create a new node. That node will point to temp. The next element, that will point to node. It's the same shit. Won't make any difference. Right. I regret that penalty I got in the first problem. Minimum seconds to equalize a circular array. You're given a zero-indexed array nums containing n integers. At each second, you perform the following operation on the array. For every index I in the range 0 to n minus 1, replace nums I with either nums I or nums I minus 1 plus n, okay, and either nums 1 plus I plus 1 mod n. Note that all element gets replaced simultaneously. Mm-hmm. I get it. Return the minimum number of seconds needed to make all elements in the array nums equal. So let's try to understand what element this actually represents relative to index I. This one is going to be the next element. If it's the last element, it's considered in a very circular fashion. So if it's the last element, we'll consider the first element of the array to be the next element of this index. And what does this represent? So this basically represents the previous element. If you look carefully, the n has been added to handle this case. In case if it's the first element, then the previous of this element is going to be this 2. So each element we can either replace it with itself, or we can replace it with the element next to it, or element which is previous to it at each second, right? will become equal to 1, will become equal to 1. They can be up to 10 to the power 9. It will become equal to 3. It will become equal to 3, and now finally this will become equal to 3. Right. hmm So it has to be one of the elements from the array, right? So if we think greedily, we'll say the element which is occurring most number of times. We'll choose that element. Will that work? No, no, it won't. It won't work. Simply because if the elements are continuous, we can at max have two new elements after each second. But if they are occurring like with the gap of one element between them, they can be instantly converted to the element that we want to achieve in just 1 second. This is huge. Okay. Okay, one thing that is very easier to understand is that things are gonna reduce in future. Like, is it gonna reduce or increase? It's gonna reduce. It's not gonna increase. So what we can do is for every number we can have some kind of a scope. For one, I can take this down. I can take this down as well. This is already taken down. Hmm, cool. the answer to this question is going to be okay, this is something which clicked after a very big time, but for all the elements in the array, it's going to be equal to the smallest of the largest difference between um, any two pair of the same element. I know it's very difficult to convey it in the words, but I think the thing that I have in mind is correct. So for one, will for every consecutive, not consecutive, but every next pair of one will take the difference. Like if we had another one, we'll take the difference again, and we do it for every number. And for a number, we'll only consider its maximum difference. And for all numbers, we'll consider the number with the minimum maximum difference. Right. Cool. And that maximum difference is the answer. Okay. In this map, we'll show the answer. In this map, we'll show the previous occurrence of that element. And now we got an element. If it simply does not exist, the maximum difference could be equal to 1, right? If it simply does not exist, 1 by 5, we'll insert it. Otherwise, we'll consider the previous and we'll take the absolute difference. Here comes I. It should be previous. It should be previous as well. Minimum of the thing that we already have, or the absolute of the current index minus the previous index. And previous of numbers of I will become equal to I. I will return divide by 2. Interesting. If it does not exist, we'll insert it. If it already exists, we'll try to store the minimum. Okay, okay, I get it. I think we do not need this as well. Answer will be minimum. Yes. One, one, one. It's very difficult to handle a few cases that I have in my mind. Why is this? This is one. This is true. That should have been zero. I think just doing answer plus one divided by two is enough. That won't make any difference in the answer we're getting, but make things easier for you guys to understand. Answer is minimum of this is fact, this one is fact as well. For this case, why are we getting one? P is again equal to that times of I to the minimum of times of absolute of. So yeah, answer was at the end equal to one. Okay, okay, okay. We get it. Should be answer divided by two. We don't want to take or do we? Yes, we want to take that one. Equals and one. We just don't care about that extra gap we were encountering. So, oh, we consider maximum of that. Mm-hmm. Okay, there are a few things that I have to take care of before I move forward, like from starting till this position. The first and the last occurrence of every element. I'll have to consider that as well because right now I'm just taking uh, consecutive elements into consideration. Okay, I think I can do that. Not absolute, but and minus fast index. This first index of I. I think I'll have to minus subtract one as well, because those that's equal to this. Yes, that will become equal to one. This is zero. Yeah, right. So basically, we were considering more consecutive elements, but we'll have to consider this circular element as well. Like in case of circular, it will form a circle from towards the left, and it will this three will form towards the right. So there are like three elements in between. But earlier, what we were doing, we were only considering consecutive difference, so it was coming out to be zero. Now it's coming out to be three. We're taking the yeah. I think this looks correct. What if both of them are equal to the same element? What if they're equal to the same element? Yeah, let's have a case for that as well. This should be equal to n by 2, right? Yeah, correct. And minus 1, actually. Yeah, this is right. Let's submit. Okay, this is unexpected. It should indeed be equal to 1. What's wrong? I did check for the similar case. Answer is equal to 2 for any number. Okay, well that's it. That is that. This is a very dumb reversal. What? How? Okay, if the number is not repeating, then answer should be equal to m, right? Initially, I was taking equal to n, which was wrong, and this will work. But the consecutive element idea was pretty quick, not very quick, and it's not working as well. Wait, what's wrong? What element are we considering? I think only 9 is repeating, and the maximum difference between the 9 is I'm getting is equal to 4, which should indeed be equal to 2. What are you doing wrong? Considering the maximum. As per my logic, it should be correct. It's missing something. We either have it equal to 0 or have it equal to 7, which is n minus 1, 2, 3, 4, 5, 6, 7, 8. Yeah, right. This is right. So we don't have any problem here. If previous is not present, we'll make it equal to I to continue. Let's check for the answer. 9 we got 1 for 9 we got 1 again. Oh, this is dumb. I'm honestly very dumb. To be honest, with you, very dumb. That was dumb. I couldn't be that dumb. Apparently, I was. So there are like 6,000 submission and only 800 acceptance. So a lot of people have been getting wrong answer, but I think I got like 4 wrong answers till now. We'll have to compensate on this problem if I want to get a better rank. I think the little hint I gave was enough for the idea to solve this problem. This is bad. I don't know what was wrong with the initial approach. I got a penalty. Uh, I'm expecting a bad rank because there are only like 800 submission and it's not that accurate. So worst case, let's say there are like 1200 submissions. And let's focus on the fourth problem. Minimum time to make array sum at most x. You're given two pseudo-indexed integers array, nums1 and nums2 of equal length every second for all indices 0 to nums length. The value of nums I is incremented by nums2 I. After this is done, you can do the following operations. Choose an index 0 to I, 0 to nums1 length, and make nums1 equal to 0. You're also given an integer x. Return the minimum time in which you can make the sum of all elements of num to be less than or equal to x, or minus 1 if this is not possible. Okay, so it's always possible, right? If we can make it equal to 0, it's always possible. Oh, for all indices, it says at every second they will increment by this amount, and at any particular second, I can make any element that belongs to nums I, nums1 equal to 0, right? Okay, the worst case, 1200. Looks like binary search and answer, or we'll have written minus one if that is not possible. And it says there are only like nine accepted submissions, but I can see way more than nine. I think it's very tricky to handle the case in which minus one will